Hello and welcome to my video. This is the last video of the week that I devoted entirely to sequences, so if you haven't seen my other videos released in this week, please check on the top right corner of the screen. So when we are dealing with sequences, one thing we simply cannot omit is the recurrence relation, the method of defining the sequence by stating the relation between its nth term and n plus 1th term. So we are going to take a look at recurrence relation in this video. The recurrence relation is given like this: a1 equals 1, and then n times an plus 1 equals n plus 1 times an plus 1. The key here is noticing that n is here and an is here, while n plus 1 is here and an plus 1 is here. Now let's divide the both sides of recurrence relation by n minus 1 and see what happens. So we have n plus 1 divided by n plus 1 equals an over n plus 1 over n times n plus 1. Therefore, now we have a relation that can be simplified using substitution. So, letting an over n as bn, we now have bn plus 1 equals bn plus 1 over n plus 1. And we can rearrange this relation to obtain the difference between consecutive terms, that is, bn plus 1 minus bn is given as 1 over n times n plus 1. Now, knowing the difference bn plus 1 minus bn, we can calculate the exact expression for bn by using the fact that bn is given as b1, the first term of the sequence bn, plus adding up these differences from k equals 1 to k equals n minus 1. When using this method, you should keep in mind that this part must be n minus 1. We only add n minus 1 terms here. Using the relation we obtained, we have b1 equals a1 over 1, which is 1 over 1, which is 1. So we have 1 plus sigma 1 over k plus 1. Now let's express this 1 over k plus 1 as partial fraction, which is 1 over k minus 1 over k plus 1. This is the telescoping sum, so if we carry out the summation, we have 1 plus, we have 1 over 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus all the way up to 1 over n minus 1 minus 1 over n. And you can see that the terms cancel out. So we have 1 plus 1 from here and this last term, so minus 1 over n, which is 2 minus 1 over n. So we have bn, which is an over n, as 2 minus 1 over n, which is 2n minus 1 over n. So therefore, an equals 2n minus 1. And that was the recurrence relation problem. This particular recurrence relation is actually a simple one among many versions of recurrence relations, so hopefully I am going to cover many more recurrence relations in future videos. But this is all for this video, so thank you for watching. Please explore my other videos in the channel, and if you like my contents, please give it a like and also subscribe to my channel. And as always, I will see you in another video.